Hello everyone! Today on my hobby table we have relatively new toolhead from BIQU that BIQU have sent me about a month ago free of charge. This is BQ H2 V2S Lite, and at the time of the video this toolhead cost around $60, and considering package and quality of the components I think it is a pretty good price, but unfortunately not without caveats. Let's open the box and take a look at what we have inside. We have some cards and the manual. It is very nice to see blueprint in case you will have to disassemble it or reassemble it. Then we have a little box with the components. Let's take a look. We're going to do it pretty fast. Rubber ducky. This seems to be as a fiberglass tape. Little bag with goodies. We have motor cable. 3510 fan to cool hot end, key to change nozzles, very nice, Allen keys to assemble disassemble device, 24 volts 70 watt cartridge, extra bolts in case you want to screw something to the tool head, thermistor with little glass bead right here, and the key also for the nozzle. Let's take tool head out of the box. We have tool head itself and hot end. That's it. Box is empty. When I initially held this extruder in my hands, I was very surprised with the quality, weight and overall size of the tool head. This is full steel extruder with a total weight of 175 grams. This tool head doesn't come with any kind of duct or part cooling fan, but a STL4 fan duct is available in case you want to install it. We're gonna talk about it later. I'm a huge fan of levers on extruders, as for me such setup significantly simplifies filament swap process. Similar designs we have on Warren Clockworks extruder and BIQU LGX Lite. This tiny motor, which works in tandem with coated tool steel gears at 7:1 gear ratio, on paper should generate up to 7.5 kilograms of maximum extrusion force. I don't have tools to properly test such claims, but there is a simple test that I like to perform to see how strong extruder is. We're going to compare this extruder to my Warren Trident Clockwork 2 extruder on cheap bond edge gears and LDO Nemo 14 motors. In comparison, I can easily stop my Stealth Burner Clockworks extruder simply by holding filament with my fingers. You can see it's extruding and I'm holding. It's no longer extruding. I can easily hold it with my hand, which is not the case here. And I don't think in real use case you will ever need more force than this extruder can provide. And let's hold it. I can, it's extruding. It slips through my hand, but extruder is not skipping. I'm holding very tight. This is all impressive, but let's see real world printing tests. Initially, I have used black leftover PLA spool from my print farm and generated flow rate tower, which will be printed at 210 degrees Celsius. This test is designed to gradually increase flow rate from 20 to 40 cubic millimeters a second, and here what I got. I was disappointed, to say the least. But upon closer inspection, I have noticed little bubbles on the surface of the wall. This is water into the filament started to boil, and those bubbles created breakups. Right away, I have opened a new spool of Bamboo Labs filament and sliced exactly the same test, but at 220 degrees Celsius. And to my surprise, this tower finished without skipping a single step or breakup. This is perfect. So we got up to 40 cubic millimeters a second with this tool head. Right here you can see a little tensioner screw with which you can adjust gears tension for materials with different stiffness, and I have spent about an hour tweaking TPU profile to print SandSmart Neon 9580 TPU. Initially I took part with a lot of retractions and was able to get this result. Printed mostly fine, but something happened at the end of the print. I think I can spend few more hours and get decent results printing 95A. But current experience says that this extruder most likely won't be able to print softer TPUs. If you got different results, please leave your comments with settings in comment section. I will definitely try those. On the other side, printing ABS, PLA, PETG not a problem at all, considering that this kit comes with 24 volt 70 watt heater and can run at 270 Celsius. It is worth to mention that this toolhead has very nice variety of mounting holes. BQ also shared mock-up step file, which you can use to design around without wasting time to measure things, holes, distances and other stuff. I wish they would do the same for Hermit Crab 2 plate. I'm going to unscrew bimetal copper titanium heat brake, which is fixed with the screw right here. And it is very nice to see they use thermal paste right here, which effectively will help to transfer heat between heat block and radiator. Unfortunately, that is the last nice thing to say about this hot end. And we will start with the nozzles. Those are custom made, and when unit was initially released, there was an issue with nozzles availability. At this point, you have opportunity to pick nozzles from different materials in different sizes. There is even hardened steel nozzle, but it is still custom made nozzle. And right now, let's mount heater cartridge, and I will show you a second problem with this heat block. Heater cartridge not even screwed to the heat block. Huge question why. I don't think it would add too much of a machining price, but considering that we deal with all metal extruder, I would prefer not to have dangling wires around my tool head. Next problem is that we don't have nozzle sock, which usually helps pretty well to prevent filaments sticking to the heat block and making a mess. Also usually saves good amount of energy holding temperature at more consistent level. Though in this package you get what looks like fiberglass tape, which I hate, due to little fibers falling around after it goes through multiple heating cycles. But it is at least something. Next problem is laying down very deep into the Vulcano hot ends. Those are very stringy. I have tried to print multiple retraction towers, and you can see right here that there is pretty much no value where this hot end is not stringing. The only way to battle it, print very fast with fast travel times. What is nice thing, I have seen on the BIQU Tech website that someone actually installed Vulcano heat block on this tool head with a sock and like mounting screws for the heat cartridge. We can install smaller heat block that will prevent leaks. We can have sock and we can have mounting screws for our heater cartridge. And that will make this tool head much better. Here's how I'm using it. This is fully assembled tool head on a Hermit Crab 2. I'm using a fan duct. STL is available on BIQU Tech GitHub repository. You will need 4020 fan. I have plenty of those from my stealth burner mods. And you just pretty much simply assemble it, putting some shims. All parts are going pretty well together. And this fan is more than enough to cool this hot end. I have printed several parts right here. Here's our cube. You can see that stringing that I was talking about. Other than that, this part looks pretty decent considering that was printed on Ender 3. You can see cheap motors VFA out there, but other than that, there is no patterns from the extruder. Here's extruder test. There is no patterns again, only VFA from the motors. To summarize, I remember times when I have spent more money to buy Dragon hot end. And for 60 bucks, this is a very good light tool head with quality machine extruder parts. But heat block quality prevents it from being a killer product. BQ stopped one step away from having an ultimate tool head. Perfect all around, right out of the box, and I think it is something that they can easily fix. If you have different opinion, please share it. Leave your like. Thank you for watching this video and I see you at the next one. Bye bye.